Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, dear students of Senior 3 Chemistry class. We are still on unit number 11, which is Petroleum Products and Polymerization. So we are still on that unit number 11. This is our lesson number 2. We'll talk about the polymers and additional polymerization. So polymers are one of the products. They are obtained from the products of petroleum. So they are products of petroleum or crude oil. So that is why I said we are just going to look at these substances. Most of other products, we'll be looking at them later as we move on. So dear students, I also urge you to pick your pen and a notebook where you will be writing some information as we move along together in the lesson. Please, you are welcome once again. There we go. The word polymer, probably you have ever heard about it, but this word polymer comes from a Greek word, poly. It comes from a Greek word, poly. And poly means what? Probably you have ever heard about that. Poly means many. Many. Poly means many. So it is a Greek word that is made up of two words. While mass means parts or single units. That is where the word polymer comes from. Therefore, polymer simply means many parts of organic compound. Many parts of organic compound. So when we say many parts of organic compound, we are referring to polymer. They occur naturally or may be artificially made in industries by joining small units called monomers. So these are some of the important words that you should not forget, that you should note down as we are moving. Polymers can occur naturally or artificially made in industries. And if they are artificially made in industries, then in industries they have to join those small units, the single units. Those single units are called monomers. Monomers, mono means one. Mers, we have seen above, that means parts. So that is where those single units are joined together to form one bigger organic compound, which is called polymer. So the process by which they are formed is called polymerization. Polymerization. Polymers and fibers can be classified into two groups. So the process of making polymers is polymerization. Polymers are made of monomers, joined together. The small units, small molecules, joined together to form a bigger molecule, which is called a polymer. And the process of making this bigger molecule, or a polymer, is called polymerization. So polymers and fibers, probably we have introduced another word, fibers. Fibers are also, it is the word that is used interchangeably with the polymers. But not all polymers are fibers, but all fibers are polymers. That is something that you'll need to know. As we go along, or as you make more research, you will find that the word polymer and fiber are sometimes used interchangeably. And they are classified into two. So we can classify them into two groups. Natural polymers, and which are these natural polymers? That is the first group that you should remember. One class, we said polymers can be classified into two groups. They can be natural or they can be artificial. So the natural polymers are living, all the living things contain polymers. If you talk about proteins, if you talk about carbohydrates, if you talk about wood, natural rubber, these are all polymers. But these are substances that exist in living organisms. That's why we say that they are natural polymers. These are some of the examples of the natural polymers. These polymers, sometimes natural polymers and fibers, these are some other examples. You can have starch, you can have cellulose. The cellulose are found when you have cellulose, e.g. cotton, wool, paper, and silk. All those ones contain cellulose. Proteins, glycogen, fats, rubber. So we have, when it comes to rubber, we have artificial rubber and we have natural rubber. We'll also look at it later on. So that is the first classification, natural polymers. So we have those as examples. Those are some of the examples of the natural polymers. Those are polymers, they are molecules or macromolecules that exist in living organisms or living plants. Another classification or another category is synthetic polymers. Synthetic polymers. These are polymers and fibers that are man-made. Man-made. They are made in industries. There are other bigger molecules that are made in industries. These are some of the examples. Polythene, probably this sounds familiar. When we talk about the polythene, this is the one that is used to make the polythene bags. You know, polythene bags for packaging. You see the packaging in supermarkets, in places of the shopping places and many others. Those are the polythene bags. The polychloroethene, which is commonly known as PVC. We're just highlighting the examples, but we'll have to look at them and probably give some uses later of each of those. Polyphenylethene or polystyrene, terrarene, nylon. This is nylon you are familiar with that is used to make clothes. There are clothes that are made of nylon. And then we have perspex. This is the artificial glass. So all these are some of the examples of the synthetic polymers. They are macromolecules that can be made in industry. There are other the natural polymers exist in nature, in plants and animals, living organisms. So you should remember those classifications. Polymers can also be classified as either, this is another classification. So we mentioned that we have two classifications. We have natural, we said we have natural polymers. This is one classification. We have artificial polymers. This is one classification. So another classification that we are looking at, apart from this, we can also classify these polymers as either linear or non-linear. Or this can be branched. This can be branched. So this one will depend on how the monomers arrange themselves. How they arrange themselves as they are joining. Monomers, how they arrange themselves to form a polymer. This is one of the examples here that we are just looking at. Just look at the screen. You will see this is a monomer, this is a monomer. They are arranged in a linear form, in a line form. So that's why we call them linear polymers. Look at these wonderful animals here. How are they arranging themselves? That is kind of if these animals were to join and they become very many, so they would be, so the line would be continuous if they join in that form, in a line form. So that is one of the examples that we can show as in linear form and so on. So these monomers keep on joining together. 1, 2, 3, 4, 100, 200, 1,000, 2,000, and so on. So that is another classification. So we can see that one. This is one linear, although it is linear, it can be also in a zigzag, but you can trace the starting point and the end point. So when you look at this one, you may think this is not linear. So, but this is a linear molecule. So when you can trace the starting point, you move like this, you move like this, you move like this, and at the end of the day, you see this is one end, this is another end. So it may not be in a straight form like this, in zigzag, but in the form of a chain. You know how the chain is. When I talk of the chain, like paper clips. If you look at the paper clips, how they are joining each other. So that is how the linear form of the molecules look like. This is blanched. So these molecules, you see, you cannot have one terminal. So you see there are branches. You cannot have the starting point and the end point. It is continuous. You see? It is continuous, but with different branches. Just look at this. This is a branch. This is another branch. So it goes. This is another branch. This is a branch. This is another branch. So it goes. It keeps on branching. And that is one other classification. Linear or non-linear or branched. That is what we also can classify polymerization. So synthetic, if we go back on the first classification of natural and artificial, so the artificial can also be called synthetic, made by synthetic polymers are made by polymerization. There are two kinds of polymerization, two processes under which polymerization takes place. So we have addition polymerization. We have addition polymerization, addition polymerization, and then we have condensation polymerization, condensation polymerization, condensation polymerization. So we are supposed to look at polymers. We have seen the polymers and the classification. And the second thing that we are supposed to look at is addition polymerization. So we look at the condensation polymerization later on. So these are processes of making polymers. There are two ways how polymerization takes place: through addition polymerization and condensation polymerization. So let's look at the addition polymerization. Slowly, when you look at this, just go on the screen, you'll see addition polymers are formed by joining up of many monomers, many monomers, and only occurs in monomers that contain double bond. That is the main important condition. For addition polymerization to occur, one condition is that it only occurs in compounds containing the double bonds. Compounds containing double bonds are only ones that will undergo addition polymerization. One of the bonds breaks and forms a bond with the adjacent monomer, with the polymer being formed containing single bond. We'll just look at that one in a short while. Many polymers can be made by addition of alkene. Others are made from alkene monomers or containing chlorine or any other atom. The name of the polymer deduced, putting the name of the monomer in brackets, adding poly as a prefix. So what I mean, if you are naming a polymer, if the polymer is formed from ethene, that is the example. So what you only need to do is to add the poly. That is the prefix that you add. So it becomes polyethene. If it is from propene, propene is another alkene, then this one you add the word polypropene. Just as simple as that. That is how we name, these compounds or polymers. If you have probably phenylethyne, this one will give phenylethene, which is commonly known as polystyrene. Polystyrene, you have seen these cups that we usually, when we are taking tea, when like these portable plastics, where they usually add tea as you are on the journey and you have no time to sit in the restaurant, they add some tea and it keeps the tea hot. It is polystyrene cup, disposable. So that is where we get this. So that is one of the examples. So what we are saying here, as they are being formed, so you'll have ethene molecules. These are ethene molecules. This is ethene. N molecules combining together at high temperatures and pressure. Then this, as they combine, the bond breaks. So you'll have this one as indicated. So the bond, the double bond, one of the bonds is breaking, and it forms a single bond. So that means N molecules, very many of them combining together. This is chloroethene, and then it forms polychloroethene. This is ethene molecule here. It forms polyethene. Chloroethene, polychloroethene. That is the naming, which is very simple. You have propene, it forms polypropene. You have phenylethene, then it forms polyphenylethene. So the naming is that it is just adding a prefix poly to the name of the monomer. That is how we name those compounds. Methyl propenoate. Now this one, methyl propenoate, not methyl propanoate, because this one, it contains two functional groups. It contains an alkene, and at the same time contains a carboxylic acid. So this is like, no, it contains an ester. So that is why we call it methyl propenoate. Penoate. P stands for that double bond. So this one will form polymethyl propenoate. That is another example. Rubber, this is another example of addition polymers. We have artificial rubber and natural rubber. An example is one you use to erase the drawing using a pencil. That is very common. When you are using a pencil and you want to rub, or you look at the soles of the shoes, the rubber tires, they are made up of rubber. The car tires, sorry. Rubbers are plastic materials which are elastic, and they can be natural or synthetic. We have artificial and synthetic. So natural rubber is 2-methyl-butyl-1-diene. That is the chemical name. 2-methyl-butyl-1-diene. That is the structure. So this 2-methyl-diene, so that means it will undergo polymerization, addition, adding together, and then the double bond breaks. You see this double bond here breaks and then form another. This one will break and form another single bond here. Just look at what is happening. So it still has a double bond. So the natural rubber, this one that is used for making the car tires, the soles of the shoes, and even this for making the erasers on your pencils, These ones contain 100 to 5,000 molecules of the rubber. There are some trees that contain these substances. Natural rubber is obtained from rubber trees. There are some rubber trees. And these trees produce milky substance, which is called latex. You have seen some trees that produce some milky substances, liquids, emiens. So they produce a liquid, so rubber looks like that. And that means if that liquid, if it cools down, then it becomes sticky. That is how rubber is. So it is a mixture, latex is a mixture of rubber and water. The latex is collected from incisions in the trunks of rubber trees that then taken to the factory for processing to produce the actual rubber that is used for making other raw materials. During processing, acid is used to coagulate the rubber, so to solidify it. The solid rubber can then be made into different shapes for different uses. So we look at the pure rubber is very soft and sticky. However, its physical properties can be improved or modified by heating with sulfur. And this process is what we call vulcanization of rubber. So vulcanization of rubber is adding sulfur to rubber for hardening, improve its properties. Call it vulcanization. Vulcanization of rubber. This is sometimes called hardening. Hardening of rubber. By adding sulfur, and when sulfur is added, its properties will be improved. It becomes harder and becomes strong to make the shoes, make the floors, to make the car tires, and so many others. Otherwise, rubber that is obtained from the trees is very soft and it is sticky. And actually, when it is exposed on the sunlight, it may dissolve. So to make it harder, they have to add rubber, or rather they have to add sulfur, and that is what we call vulcanization of rubber. Synthetic rubber. So because of the disadvantages associated with the physical properties of natural rubber, which we said it is very soft, sticky, and tough or rough, so it has to be hardened. So synthetic rubber has been made, which is more stronger. Synthetic rubber is more stronger than the natural rubber because we said natural rubber is soft, sticky, and sometimes it melts at low boiling points. It melts at low temperatures. And therefore, synthetic rubber has been made in a way that for it resists action of oils, so the other substances cannot dissolve it. Abrasion, that is like wearing off of some other substances. So this natural rubber is poly-2-chloro-butane-1,3-diene. So that is the natural, this is the synthetic rubber. We said artificial rubber is 2-methyl-but1,3-diene. When the synthetic rubber is 2-chloro-but1,3-diene. So that means the difference is on the methyl group. 2-methyl, that is the artificial. So natural rubber is obtained from 2-methyl-but1,3-diene. That is the chemical name. This is the monomer, small units. So they will join up together to form poly-2-methyl-but1,3-diene, which will be natural rubber. Whereas the synthetic rubber, will be 2-chloro-but but 1,3-diene. So that is, so if it is these molecules, these are small units, these are monomers. So when they join up together to form the synthetic rubber, this is the monomer, this is not the rubber. So the monomers are these. But when they join together, then we said we add the word pore, which becomes pore to chlorobut-1,3-diene. And then here we have pore, so you just add it on to this one. And therefore, that is what it becomes. We said synthetic rubber is more stronger because it resists abrasion, being dissolved by or wearing off of other substances, and therefore that's what makes it strong. Why synthetic rubber? Because we said natural rubber is soft. That is one of the disadvantages. It is very soft and sticky, and the boiling point, and that actually melts at the low temperatures. Dear students, this is what we are supposed to look at, the polymers. The classes, we have looked at them. We looked at the method of performing polymers, which we said is polymerization, and then we look at the other classification, the processes of making polymers. We said there are two: addition and condensation. So we're supposed to look at the addition, and we have looked at the naming of how these addition polymers are formed. That is what we're supposed to look at for today. Thank you so much, dear students. Please stay safe, and I hope we meet in the next lesson. Bye-bye.